We're going live, and we are live. Oh yes, what is up, everybody? Welcome to another Data on Kubernetes meetup, a doc talk. This is our second student session that we're doing with the CNCF students group with my main man Kunal Kushwaha, who's a CNCF ambassador along with me. Very excited to be here. We got a lot of things that we're going to do, which is why we even decided to start a minute early so we can kick things off properly. I know some of you folks have been waiting. Today we got a couple of special things we're going to be doing. The first one we're going to be doing is we're going to make history. We're going to have our first Data on Kubernetes a cappella rap, 100% live with no beats. All right, we're going to get really crazy today because it gets a little bit weird when we're sharing videos. Sometimes it gets a little bit buggy. So I thought, you know what? We're just going to do things a little bit differently. So if you bear with me really quickly, I'm going to put this together. I'm going to throw this out. Let's see if I can do this. Oh, by the way, everyone, hello from Madrid. Today I'm in a different city in Spain. So check this out. DOK, CNCF students, we're rocking this serious stuff today. Got a lot of positive energy. Got a lot of stuff we're going to be doing. Yo, check this out. Yo, students, it's a movement making new rent out of 2 cents. It's the hunger for knowledge. Pay your way through college. Always forward on your feet. Pick up the phone and you call it. Pick up your hands and you shake them. You know this is iron will, can't break them. Real deal, can't fake them. This feeds my meal, you can't bake them. Talking about the future is here and the wounded bird can steer. These haters, more like debaters that just can't make up their minds, are getting crunched like some potatoes on some salty ass rhymes. These are the students from the CNCF. That's the coolest, newest chapter forever. You can hear it until you breathe in from the depths. Clever competitor, progenitor of servants, leveraging, hemorrhaging on some predators, editors, senators, get to the chopper, minerals heavy like copper. Last session was Docker. KHB electrified like metal plates. You can call it the shocker. You can Star Trek it, yo, you can call that the sparker. Fast feet, that's a walker. Ranger, Texas, don't fleck this. On your door like knockers. Out of time, that's a clocker. Shots on, that's a blocker. It's Doc up on your block. You can call us the talkers. And that's how we're getting started today. Fresh energy with a nice rap. I'm sure we're getting wonderful comments right now on YouTube. Good to see everybody here. Like I said, today I'm joined by Aitor Artola, who's a legend, who's a veteran already in the Data on Kubernetes community. This is going to be his first session that he's doing here today, is an introduction to Kubernetes, which will be followed by Kunal, who's going to be giving a talk about from college to cloud native. Got a very special announcement about Kunal. Kunal has been helping us out for a while in the Data on Kubernetes community. He's no stranger to our community. He really understands community. For those of you who were lucky enough to attend our KubeCon co-locate event on May 3rd, Kunal gave a wonderful talk about scaling communities. Someone who obviously has tons of potential, connects extremely well with young people, very well integrated in the CNCF ecosystem, constantly giving talks, has a bunch of different things he's got going on. Because of that, in the DOK, we're very serious about engaging with young people, which is why we're doing these sessions. Personally, I gotta say, probably my favorite sessions that we do are the ones that we do with young people because of the freshness, because of the new ideas, because of all the really good energy. So because of that, we decided we need to really take this seriously and we wanted Kunal to work with us. So we reached out, and from now on, Kunal is going to be the inaugural founding student program manager for the DOK. So we can all give a big round of applause. Very excited to have Kunal with us. That being said, also very important news that we said we're going to tell everybody today. We're going to be launching the application process for you, the students, to become interns in the DOK. I will be putting the links inside our Slack. Another thing about Slack today, with all your questions, you can put them in the YouTube chat, but it's going to be much easier for us to answer them if you put them in our Slack in the beginners questions, Slack area. That's also where I will be pinning the application process and the Google Forms that you have to fill out in order to apply to be an intern. I want to say really quickly, being an intern, you do not have to have technical coding experience. That's helpful, but it's not the only thing. A lot of the internship experience is going to be building the community, all right? Working with me, working with Kunal, working with the other people on the DOK team to help us extend this community, to expand this community, to make it stronger as we continue to grow. All the details will be lined out in the document that I'll be sharing in Slack right now, all right? So you can get all the details on that in terms of how long the internship is, the stuff that we're going to be doing, the things that you're going to be getting in return, all right? The valuable experience in terms of learning different things about social media, about how to build a community, mentoring opportunities with different people in the community, and the different things that we'll be doing to help you jumpstart your career in tech, all right? So like I said, all that info is going to be there, but like I said, very excited to be announcing the welcoming of Kunal as our student program manager. So that being said, I'm going to be quiet and I'm going to turn it over to Aitor so he can get started. Like I said, Kunal will be back later to do his session on From College to Cloud Native. You'll definitely want to check that out as well. I think that's pretty much all I got. So Aitor, if you want to take over, it's
Yeah.
all on you.
Okay, let's start. So I have some problems with my my mic. So let's see whether everything goes okay. Yeah.
I'm sure it'll be fine. Don't
Can
worry.
you see it now?
Perfectly.
Let's start the presentation. Okay, so welcome to everybody. Today I will be talking about Kubernetes and containers. Well, I heard that this is just an introduction, so I might have been a bit over ambitious with this because I have plenty of material to show you. But I hope that you'll find all of it interesting. So just to go quick, because otherwise Bart will get angry with me. Just a brief introduction about myself. My name is Aitor Artola. I have been working with Kubernetes for over 3 years, pretty much, and I'm working in a platform called Lainotik, which goal is actually to deploy on Kubernetes big data, IoT, and artificial intelligence technologies in just one click and in a matter of minutes. The whole idea behind Lainotik is to have everything ready so our customers can actually start working with things that are interesting for them, which is actually the getting value from their data. So I'm going to move on quick to the presentation now. So the first thing that I'm going to do is a brief introduction of what Kubernetes is. Well, Kubernetes is a software that sits between the applications and the infrastructure. Infrastructure that could be a cloud-based infrastructure or on-premise data center infrastructure. The whole idea is that container, what it does is actually creates an abstraction of this infrastructure, right, in such a way that applications, containerized applications, can work on top of this abstraction without knowing exactly the details of the underlying infrastructure. So at the end of the day, what you get is from Kubernetes, what Kubernetes will do is automatically run and manage containerized applications on any cloud or on-premise infrastructure. So that's the summary. And this is what I'm going to expand during my presentation. But there is also something important, something else important to know about Kubernetes. And this is that Kubernetes is a cloud native project. And what does it mean really? What is a cloud native? Well, cloud native is an initiative driven by a foundation called Cloud Native Computing Foundation. Just to give you an idea, all the major big software cloud infrastructure companies are involved with this foundation. And what is this initiative trying to do? Well, actually, it's trying to establish the foundations to build and run modern applications that are scalable, loosely coupled, resilient, and observable, right? Or then to work on any modern dynamic environment. Here we are talking about the public, private, and hybrid clouds, all based on managed through a robust automation for frequent and predictable high impact changes with minimal toil, and all of it based on an ecosystem that is open source. So and it's vendor neutral project, so you don't have any vendor lock-in. Okay, so here what we are talking is on a new way of building and running your applications, right? And Kubernetes and the containers are just tools to achieve this. But in order to jump from the traditional way of working with applications and to move into these new modern applications, a new mindset is required, because for this, there will be a need of a cultural change. We need to do things differently. And something like that is not something easy to achieve. For example, looking at the CNCF survey report done in 2020, when it was asked what were the main challenges in using deploying containers, the first one was complexity, which is understandable considering that all this technology is pretty new. But the second one was actually cultural change, the difficulty to address all this new way of working. So this is what I'm going to try to clarify today as well. So it will be about Kubernetes, but the reason behind and how to use that will also be, I will try also to explain that during this session, okay? So to get some context on how the presentation will be, I have divided that into three sections, okay? The first one will be related to Docker and containers. I have been told that you have already attending a presentation regarding Docker, so I'm not going to extend too much on this, but I will actually emphasize on the benefits you can get from containers. The second one will be obviously Kubernetes, which is the main topic of my talk, right? And I will finish talking about the cloud native, because I think understanding Kubernetes without the context of cloud native could be a bit misleading, okay? So let's start with Docker and containers. And here, what I'm going to do is I'm going to talk to you a little bit about the differences between the virtual machines and containers. Then I will give a brief overview of what Docker is. And then I will talk about the benefits you can get when you use or deploy your applications with containers. Okay, so let's move on quick. Virtual machines versus containers. So a bit of history here. In the old times, or if you had an application, you would deploy that in just one machine, a big machine, right? A mainframe. But in the 70s, a technology called virtualization became quite popular. And here was the idea. What you would have is a machine, which I will call it a host machine, where you would have your hardware and your operating system, a normal machine, right? And in that machine, you would have running a software called the hypervisor. So the idea is that this hypervisor would virtualize the host hardware in such a way that it would create software-defined virtual machines, and each virtual machine, or all the virtual machines would be sharing, thanks to the hardware virtualization, the infrastructure of that physical machine. Okay, so with this, you actually could get quite a lot of benefits. The first one is that if you had an application running in one virtual machine and another one in a different virtual machine, so you wouldn't have any interference between them. So you would get better stability. And the other one was actually that you could, if you need it, if you need to spin up a new machine, right? You would just ask the hypervisor to do so, and it would do that in a matter of minutes. So it was much more flexible. So considering these benefits, right, the virtual machines became quite normal after the 70s, right? And it continued this way even during the introduction of the cloud computing in 2006 with AWS. At the end of the day, the cloud, what is offering is different kind of services, and one of them is the infrastructure as a service, right? But what they do is really they offer you infrastructure, virtual machines that you can actually get on demand with a pay per use model. Okay, so everything was going in these directions. Virtual machines were popular, but something happened in 2013, right? And a company called .cloud presented a tool called Docker that was able to manage containerized applications, right? The containerized application concept wasn't something new. So Docker didn't add any revolutionary technology, right? But what Docker did is facilitated the use of containerized applications, and everybody could see there the huge potential that was behind there. Yeah. So its popularity became well. The containers became so popular that the same company, .cloud, actually changed its name to the product name, right? So it started calling itself Docker. And in just 1 year after, Google released an open sourced another project related to containers. It was a container orchestrator called Kubernetes, okay? That is the main topic of my talk today. We will talk about Kubernetes later. Let's focus now on how the containers work. So the idea here is that you have a similar machine as the one used for virtual machines. But instead of having a hypervisor, what you would have is a container engine. This container engine will virtualize not just the host hardware, but also the host operating system. Thanks to that, then you would have for each application a container, yeah, and all these containers will be sharing a host operating system and hardware resources. So note here a big difference between a container and a virtual machine, and is the guest operating system. So each virtual machine has its own operating system, while the containers don't have the operating system because they actually share the one provided by the host machine, right? And this one provides actually quite a lot of advantages. And here they go. The first one is that the boot up time for the containers is much faster than for the virtual machines. The other one, for the same reason, for not having the operating system, is that they have a much smaller footprint. Yeah, so they are lighter than the virtual machines. Their consumption or overhead of memory and CPU is much lower. And what is more important, there is an extra property that I will explain later in more detail, that is portability. So portability, what containers allowed is to execute a containerized application in different environments with the certainty that they actually would work. Something that is not that obvious with virtual machines. Okay, so note all these benefits of the containers and especially the part of portability. Now, if I move on, I will now talk about Docker itself. As I said, it seems that you have already had a presentation about this, so I'm not going to extend much. But in Docker, what Docker is actually is a tool set. You have different tools, right? You have the Docker CLI, a command line tool. You have the Docker host, and then you can have a Docker registry. So the idea is the following. If you want to deal with containers, what you would do is you would define a regular file called Docker file, where you will set the instructions that you will pass to Docker to create containers. So as you see in this example, you have a Docker file with several instructions, 4 in particular, right? And in each of the instructions, you say what kind of software should be added to a container. When you do that, what Docker will do is actually will create one layer with the software defined in one of the instructions, and then for each instruction we'll go creating a new layer. So it's a layered kind of a structure that you will build with Docker. Okay, the first layer is called the base layer, right? And the last one, it would be defining the entry point, which is the executable that will be executed once you start running the container. Okay, so once you have this defined, then you will go through, you will use the Docker CLI, and through this you will request all the actions you want to do. The first one will be to create a container image. The Docker CLI won't do that work. Actually, we'll pass this request to the Docker daemon that is located within the Docker host. This Docker daemon is going to take all these instructions that you have in your Docker file and will create an image that will be stored locally. Then you can ask also to push or pull that image. In that case, that instruction again will go to the Docker daemon, and what the Docker daemon will do is actually push that to the Docker registry where the container image will be stored, or it will pull that image from the Docker registry to have it locally stored. Okay, and finally, the one that probably is the most interesting one, you can have also a command here to actually run the container. In that case, when you do that, the Docker daemon will actually get the image. If it doesn't have it locally, it will pull it from the Docker registry and will create an instance of that container. Okay, this way you will have that container running in the Docker host machine. Okay, so in summary, important to understand here, Docker builds and manages containers. Okay, it's a toolset that allows to manage containers. Now, I will move more now to evaluate or to analyze the benefits you can get from containers, because I think this is the basis for what I'm going to tell you later about Kubernetes. So let's see some of the properties, and I will go back to one that I mentioned before, portability. And to understand this, consider the traditional way of developing and deploying applications. So what you, as a developer, you would be doing your development with your own local machine, yeah, doing everything that you need to do there, like testing and debugging and everything, right? On the other side, you will have the operations guy or the sysadmin, right, that will prepare the different environments where your application will be executed. I'm talking here about test environment, integration, or even production, right? Once you have the developer has that finished, what he will do is he will deploy that into the different environments. In theory, this application should work, but sometimes, and is more often than we would expect, that is not the reality. So the application actually doesn't work. So here is where it starts the conflict between the ops guy and the developer, because the developer will say that the application works on my machine, right? That will be his answer. So what happens here? Well, basically, because the application is working on top of a operating system and libraries on the local machine of the developer, developer, right? When it is, let's say, deployed into another environment, it means that that application will be running in a different, or might be running in a different operating system and set of libraries. And that is what can generate this conflict and this failure, okay? So the interesting thing is that with the containers, that is not happening anymore. In a container scenario, what you would have is the developer developing its software or its application in the local machine, of course, but on top of a container engine, okay? It will create a containerized application, we'll put that into the image registry, and it will be then deployed into the different environment, test, integration, or production. The Ops guy has prepared these environments, yeah, and it will make sure that it has all of them with the container engines. So having this, because you have the container engine and there is no operating system involved, you are sure that the application that you are developing in your local machine is actually working, will be actually working in the different environments you are going to deploy this, okay? So portability, this is what you achieve with the use of containers. So which is the same environment consistency. The other benefit of this is that you have a dev and ops separation of concerns. Yeah, operations know how to do what has to do, and development knows what to do. Development of the application, of course, but there won't be any conflict between them. So everybody will be happy with that. And then the other important thing about portability is that this helps you to establish a more reliable and frequent continuous integration and continuous delivery pipeline, which is something very important, as you will see later when we are talking about the cloud native initiative. Okay, so I'll continue with this. The second approach, the second benefit of using containers is actually reusability. So I mentioned before that through the Docker file, what you can do is you can actually set the different layers that will compose a container image, right? You can request Docker to build that, and then you can push it into the image registry. So the first benefit is actually that somebody else can actually take that machine and benefit from your image, okay? Now, the other interesting thing is that a container image can be actually the base instruction or the base software for a new container, which means that you can actually build a new container image based on the previous one. With this, you would have the software defined in the initial image, and then you would have new layers that you are in a new Docker file that will enhance the capabilities of that new image. And you can continue doing that over and over again. So the big thing with this is that you don't have to do the same thing over and over again. You can reuse quite a lot of software and quite a lot of definitions that you already have done before, right? And this is not something that is strict to your company or your university or your environment. You can actually benefit from the images that have been created by other people. So there are plenty of public registries out there, image registries out there. And just one, I will mention just one, which is Docker Hub, which is the most popular one. And these are some metrics that I got from them. It was like 3 weeks ago, pretty much. And what they are saying is that they had 13 billion image pulls per month from nearly 8 million repos by more than 13 million developers. So there is a lot of image sharing. There is a lot of reusability that is happening here. And with this, what you would get actually, you will increase your productivity, because as I said, you don't have to repeat things over and over again. Now, a small warning here, be careful with the third-party images that you use. If that image has some kind of malicious software there, what you will be doing when creating new images on top of that one, or based on that one, you will be actually spreading the malware. So you have to be always careful and check where this third-party image is coming from and make sure that it's secure. Okay, so then I will move to the last big property of the containers, which is the following, microservices. So let's go back to the traditional way of building applications. In here, what you would have usually is a framework, Java-based or .NET-based framework, and you will be building your applications based on that framework. The framework gives you a lot of facilities to build a fantastic application, and then that's the one that you will be deploying. This application is actually a monolithic application. It's one unit, okay? But now let's take this other approach. Imagine that we can split that monolithic application into different units based on the different functional areas you might have within that monolithic applications. Now you can actually do that because you can actually create a container for each functional application, because the containers have a fast boot up and a small footprint. You can have a container for each for let's say for each functional unit and manage that independently, even though it belongs to a bigger application. Okay, so this unit is actually called microservice, and through microservices you get quite a lot of benefits, and let's see whether I can name some of them here. Okay, the first one will be observability. So think about this: you have a monolithic application, you know what it's doing, but you are not it's not easy to find out what's happening internally, right? When you have a microservice application, an application that is split into different containers, what you could do is you can actually trace the communication between the different containers and find out different levels of bottlenecks and take actions to improve that. Okay, so the microservices give you quite a lot of benefits if you have the capacity of seeing how they are working between each other. Okay, the other one is elasticity. Imagine that you need to improve one functional area, adding say more functionality, more resources. I'm talking here about CPU and memory. So in a monolithic application that would be difficult. You would have to give resources to the whole application. With microservices, what you could do is actually assign those resources to the specific microservice that you would like to I don't you like to improve. Okay, and you can even go further with this. What if a microservice is not being used during hours? Well, you can even think about the possibility of destroying that microservice and waking it up later when you need it. So with this, you would have a better use of the infrastructure resources regarding memory and CPU. Okay. The other one is another advantage is agility. So say that you have to do a change in a monolithic application, you would have to do a change, taking care that you don't break anything else within the whole application. And then you would deploy the whole application into production or whatever environment you have to deploy that, right? With microservices, the change that you would do would be focused just on one microservice. And the only thing that you had to update and deploy would be that particular microservices, which gives you quite a lot of agility when you have to do things, okay? And the final one that I will mention is flexibility. So instead of having a monolithic application with just one built with just one particular programming language, why don't have different containers that are being each one built with its own particular programming language? I wouldn't say that that's a good way to go. I mean, it's up to you guys. But the whole point is that microservices allow you to do that. You can go for a more, I don't know, fast programming language like Go or Rust, and build a particular functional area with that one because you are interested in having a better performance in that particular functional area. So flexibility is another of the big advantages you get. So just to finish with this, so regarding containers, you get portability, you get also reusability, and then you can decouple the monolithic application into microservices. These are the main things that make the containers so great. Okay, so I'm not going to extend more on regarding containers. What I'm going to move now directly is to Kubernetes. Okay, and what is Kubernetes? Okay, being how powerful the containers can be when you are building application, Kubernetes is kind of the next step that you have to follow that to make it really great. Okay, and what it does is actually it orchestrates the management of containers within a cluster of machines. Right, instead of having a container being executed just in one machine, you leave to Kubernetes to decide, yeah, how to handle the containers considering a pool of machines that you might have there. The interesting thing is that to do so, Kubernetes takes an approach called infrastructure as code, yeah, in such a way that what you would hold on a second, I'm getting some messages here. No, there you go. coming back. So as I said, it uses containers and then an approach called infrastructure as code. Yeah. The idea here is that what you would do is you actually through code, yeah, you will tell Kubernetes what you would like to have, or from how you would like to orchestrate your containers. And based on that one, Kubernetes will take quite a lot of the tasks that usually was done given to a sysadmin. Okay, that's what I'm going to try to explain to you during this section. Now, I will divide this into several steps here. First, I will be talking to you about the standardization work that is ongoing, which I think is quite important. The second one will be about the Kubernetes internals. Then I will show you how you can actually run or set up a Kubernetes cluster in your own machine. Then I will talk about the Kubernetes features. I will move to the Kubernetes architecture, and then I will talk a little bit about the challenges and opportunities that you can get if you use Kubernetes. Okay, so sorry if I'm going fast, but Bart told me that I have limited amount of time, so I'll continue. Remember that I mentioned that Docker was presented in 2013 and Kubernetes in 2014. So in 2015, a very, very strong standardization work started to happen. And it was actually in two areas. One was related to the actual containers. Docker released and open sourced its specification regarding containers, and the Open Container Initiative was created under the umbrella of the Linux Foundation. And with this, basically what Docker did was allow other vendors to prepare their own tools to manage containers. So now it's not just Docker that you can use to actually to deal with containers. You have other tools like Podman or Kaneko that you can use to do practically the same. You have to go deeper into them just to see the differences, but in essence, what they do is they manage containers. Okay. And then what I just said before, container orchestrators. So seeing the potential of the containers, different container orchestrators were created. So there you have Kubernetes, Docker Swarm, and Mesosphere. So the idea, as I said before, is the following. You have a container and you request Kubernetes or any other orchestrator to handle that. So what the orchestrator will do is will execute that container into one particular machine, right? Now, if something happens in that machine, the orchestrator itself will be clever enough to actually recreate that container in another one. So what you get this way, it's more resilience really in the applications of you are building. So they will be ready to handle failure situations of your nodes. Okay, that's the big advantage that the container orchestrators are bringing. As I said, there are several of them. Kubernetes, Docker Swarm, and Mesosphere, right? But the truth is that in the last few years, it has been clear that there is a winner, right? And that winner is without any doubt Kubernetes. Kubernetes has become de facto standard, really, when you talk about container orchestration. In any way, the standard, the way Kubernetes is built is based on standards that are driven by the Cloud Native Computing Foundation that I mentioned initially in my presentation, in the first slide of my presentation. Okay, so from now on, I will be focusing on Kubernetes, but know that there are other alternatives that you can use as well, even though I would recommend to continue with Kubernetes. Okay. So I'm not saying, I hope that I'm doing well with the time. So let's now look at the internals of Kubernetes, okay? So in order to set up a Kubernetes environment, first what you will need is infrastructure. You will need machines, right? For that you can actually access your preferred cloud provider and then maybe allocate some machines there, right? You would also need an image registry, but you will have stored your application containers. So in order to set up Kubernetes on top of that infrastructure, you have several tools. You have what are called installers like kops or kubespray or kubeadm that basically do that. They set up the Kubernetes in your infrastructure. You have another other set of tools called distributions, right? Like OpenShift or Rancher, which do the same. They set up a Kubernetes, but they add extra functionality to be able to manage that Kubernetes once it is installed. it is set up. Okay, and finally, you have the option also to get a Kubernetes as a service from many cloud providers. With this one, you don't actually do the setup. You request the provider to do that for you, so you save quite a lot of time. But at the same time, well, you have to pay for the service too. Okay, so whatever your choice, at the end of the day, what you will have is something like this: several components that will be installed in the machines that you have available for Kubernetes. Okay, these components will be actually divided into two planes, the worker plane and the control plane. So let's focus first in the worker plane. So the idea here is that each of the nodes belonging to the worker plane will be a worker, okay? And each worker will contain two components, the kube proxy and the kubelet. The kube proxy will be responsible of the communication between the workers, while the kubelet will be responsible of fetching container images and executing them within the worker, okay? On the other side, we have the control plane, where you have different components, right? The central one will be the API server, the one that is responsible of the communication between the different components, okay? Then you have the etcd, which is a database, a key value database, where all the configuration related to the Kubernetes will be stored. You will have some controllers, and then you will have a component called the scheduler that will be responsible to decide what workers should take care of each container that has to be deployed, okay? And finally, the cloud controller manager that is responsible of interacting with the cloud infrastructure, so to perform actions like, for example, auto-scaling or downscaling machines, right? Or assigning or releasing load balancers, okay? So once you have that ready, what will happen is that you will have a Kubernetes environment, a cloud native environment, and all the orchestration will be managed by the control plane together with the worker place, where you will have all the containers that you deploy. And how would it work? Well, in order to access to this Kubernetes, to any Kubernetes, what you can use is a command line tool called kubectl. And through this kubectl, what you can send instructions to Kubernetes through YAML files. The YAML files will have, let's say, a definition of the infrastructure as code, of course, that you would like to have for the applications, containerized applications you want to deploy. Then when you send that, that will go to the API server, and then the API server will be responsible of distributing that in such a way that the scheduler will decide in what worker this new container should be created. That information will reach the kubelet that is running in that worker, and then the kubelet will be responsible of getting the image for that particular application that we want to execute, and it will run that on that worker. In this way, you will end up with your applications running on top of these workers, thanks to all this process that I just mentioned. Okay, so maybe I'm going fast with all this. I hope that you got this clear, right? Now, the question is, would you need to have a lot of infrastructure to set up a Kubernetes? Well, the answer is no. You can actually set up Kubernetes in your own machine, okay? And you can do that even on top of the Docker engine. There are several tools that are available out there, like the Minikube, Kind, or K3D, that allow you to create a Kubernetes environment. This Kubernetes environment will be running, for example, in Docker containers, right? And they will provide this Kubernetes environment. So as you see here, you have 4 nodes in this example, 4 nodes that belong to that contain the Kubernetes components, right? They will be the ones connecting to the image registry. So what you would do is, with the same as you did for production, you will have the kubectl command line tool to connect to that cluster, and then through the same YAMLs, you can actually deploy that on top of this Dockerized Kubernetes. Okay. Now, to see that how easy something like this could be, what I'm going to do now is a very quick demo. So I hope that you see now my screen, right? No, don't worry too much about seeing the details, but just to have an idea, what I'm going to do is I'm going to create a Kubernetes cluster now. For that, you need 2 tools to be installed in your machine. You need to have a kubectl store, and then installed, and then K3D. If you have them, you can actually create and use a cluster in your own machine. What I'm going to do now is I'm going to call this, run this command, K3D command, and as you will see now, I hope that it works, right? What this will do is actually will create containers that will contain all the components that are part of the Kubernetes setup. In here, I'm giving quite some information. For example, I'm calling my cluster dev Lainotik. I'm saying that it should have just one node for the control plane and 2 workers. Okay, so when you request that, K3D will talk to Kubernetes and will actually create the Docker containers with the corresponding components. Okay, so in a matter of 30 seconds, you already have a cluster available. Just to make sure that everything is okay, let's check how many nodes. I will be using the kubectl command, and let's see how many nodes are identified by the Kubernetes you just installed. Okay, let's have a look. I'm going to clear that first, and let's check this. So as you see here, you have one that is belonging to the control plane, and then you have 2 more that will be your workers, right? Now I can check also what containers are installed right now. If I do this quickly, you will see that I have during the setup several containers had already been deployed. Okay, what I'm going to do now is actually I'm going to deploy my own application, and for that I have prepared something very simple here. This is, as you see, a YAML file, right, where I specify a deployment. Okay, and I will say I will request to generate 2 replicas of one container called a hello world, right? And here I will establish a reference to the container image of that container image that will be used for that. Okay, this container image is located in a registry that is actually provided by Kubernetes. So if I have this ready, now the only thing I have to do is I have to call this kubectl apply deployment YAML, right? And this one will actually, if everything goes right, will actually create the container. And let's prove this. If I call again this one, you see how the containers are being created. Okay, as I said, there would be 2 replicas, so it has created 2 containers, right, with that particular container image, right? So if we check again, you'll see that after less than 25 seconds, you have them already running. With this, you can actually build your own applications, containerize them with Docker, and then you can upload them using this a similar YAML file. Once you have finished, well, you can destroy the whole cluster with just this command over here. Okay, let's do that. And there you go. So believe me, the cluster is already gone now. So there is no cluster anymore. So as you have seen, in very quickly, I have been able to create a cluster of 1 node in the control plane, 2 in the worker plane. I have been able to deploy an application, the Hello World applications, with 2 instances, and I have been able to destroy the cluster. So if you do even more automation, you can even do things much faster, really, and deploy quite complex applications on your own machine. Okay, so now that we have seen this, let's go into details of what is Kubernetes offering. So the first one I would mention is this idea of infrastructure as code. Yeah, here I have been using Docker as my underlying, let's say, infrastructure. But if you go to production, you will be using something completely different. But the usage of Kubernetes is going to be exactly the same, because in Kubernetes you define the orchestration of your containers and your infrastructure through a infrastructure as code mode. Okay. Now, thanks to this, you can improve a lot your deployment process, and you can simplify and automatize quite a lot of things, right? Regarding the actual features, so I will mention the self-healing capacity of Kubernetes. If you have a container running in one machine, and as I said, something fails in that machine, Kubernetes will take care of that and will actually recreate that same container in another worker. Okay, so somehow is doing a lot of the work that before it was doing manually by a sysadmin guy. Okay, it can handle service discovery and load balances. I just showed you before how I created 2 instances. Okay, so if I have to interact with those 2 instances, Kubernetes will manage the load balancing between them, so managing the traffic that gets into them. Okay, manages resources. You can have pod auto scaling depending on the load of the container. You have CPU and memory allocation for each of them. You can do rollouts or deployments as I did before, but then you can also have rollbacks if you deploy something that you don't like how it is behaving. It handles also the configuration. You can deploy there, you can define secrets, configurations of the containers, even network policies to establish the communication between different containers. And it can also handle the storage orchestration. Okay, so for if you want to know more about the storage orchestration, well, there you have the data or data on Kubernetes community, where you will actually learn quite a lot of how this is being managed. Okay, so now at the end, you will end up with something like this. An environment, a physical environment, like with load balancer, storage, network, nodes, all that being managed by Kubernetes, that offers several interfaces through the Cloud Controller Manager, the Container Neighbor interface, and the Container Storage interface. And then within that, just containers that are being executed. We don't know in what machine. Kubernetes will take care of that, and we'll make sure that they are always up and running. Okay. Now, to finish, just a few challenges that we will face, challenges and opportunities, I would say. Regarding security, you actually doing it right, you can have much more secure applications. And why is that? Well, what Kubernetes provides is 2 extra layers of security that you can apply there. You can have a security at cluster level with the application of network policies, and security at container level, where you can establish the user privileges and these kind of things, just to make sure that if there is any kind of intrusion, the effect of that intrusion could be less damaging. Okay, obviously it gives you more options or more opportunities, but at the same time you have to do it right. So cybersecurity will stay always something to be taken into account very carefully, even within Kubernetes. The other one that I mentioned is, before I mentioned about this, is observability. So now that we are thinking about having lots of microservices, right, that will be running in different machines, communicating between each other, it's critical to establish the proper logging, monitoring and tracing and visualization for each of these containers. If you have that, you will have a good understanding, a good observability of your application, and you can do a lot of improvements just to get the best of your application. The storage, well, Kubernetes provides dynamic storage. Uh, because it's being Kubernetes so dynamic, right? The traditional NAS SAN systems, well, they don't fit that well in Kubernetes. So there is a lot of work going on this regard with concepts like software-defined storage. Okay, again, if you want to know more about this, I recommend joining the Data on Kubernetes community, where you will actually get a lot of information of what's going on right now. And the final point that I will make here is related to auto-scaling. So Kubernetes allows creating replicas of the same container, allows managing memory and CPU, etc. So, but if you want to really get benefit from a cost perspective, you have to make sure that the cloud where on top of which Kubernetes is running has the same capabilities, because at the end of the day, you will be paying for the infrastructure you use. So Kubernetes could be very optimal, right? But if that optimization doesn't end up in a less usage of infrastructure from the cloud perspective, right? Cloud provider perspective, well, you won't make much savings on this. And I have to say, in the cloud, it is very easy to spend a lot of money. It's very easy to create new machines, but it's actually quite easy to forget to switch them off. If you don't switch them off, even if you don't use them, you will be actually paying for that. So you have to be careful when you deal with auto scaling. Okay. Now, with this, I'll finish with a section of Kubernetes. I hope that I'm doing well. Now I'm going to finish now just talking about the cloud native, which is, um, I think, is something that is important to understand when we are dealing with Kubernetes. So Kubernetes and containers, they are technology, but in the cloud native is more an approach of how to deal with these technologies. Okay, and so far we have been talking about these two technologies, containers and Kubernetes, but in the cloud native approach, right, there are four pillars, right? Two of them we already mentioned, containers and microservices managed, for example, with Kubernetes. But there are two more, continuous delivery and DevOps, right? And why is this important? Kubernetes and containers provide a lot of potential to build great applications, but at the same time, it generates quite a lot of a complex environment. Okay, if you don't deal with that complexity, you might end up in a situation where you cannot handle your system. Okay, I'll explain that later. So in this section, I will talk about the difference between the concept of cloud and cloud native. Then I will talk to you about the cultural change that is required. I will mention automation, which is a very important point when we talk about this cultural change. And finally, I will finish talking about the tooling ecosystem you have available in this kind of cloud native environment. So regarding cloud native versus cloud. So everybody is talking about migrating to the cloud, right? But the question would be, to what cloud really? So in order to answer this, we need to see the difference between the traditional or more common cloud and the concept of this cloud native. Uh, the cloud offers infrastructure as a service. It offers platforms as a service. But the point to have clear here is that all the services are actually proprietary. Okay. So if you do a lot of use of those services, you might end up in a vendor lock-in situation, which doesn't need to be bad. But if sometimes you decide that you would like to move to another cloud, yeah, you have to be very careful with this vendor lock-in situation that you might end up, because if you want to move to another cloud, you might have to do a lot of reengineering of the everything you have developed so far in this original cloud. Okay, so something like that wouldn't happen in the cloud native, because the Kubernetes that you may have in say Azure, yeah, would be the same Kubernetes that you will have in Amazon, for example, or in Google, or in any other provider like DigitalOcean or whatever, right? So whatever you do for Kubernetes, you know that it's actually portable, right? So in here is not so much about whether you have to migrate to the traditional cloud, let's say, or the cloud native. Uh, I would say that the logical way would be to build on top of the Kubernetes environment in a cloud native environment, but then note that the cloud native Kubernetes requires underlying infrastructure. For that, the cloud is the perfect match, because the cloud offers services like infrastructure as a service and this kind of payment models like pay per use, right? So combining both is when you can get the best of it. And actually, the cloud native approach is trying to actually find this big match between them. Okay. Now, regarding the cultural change that I mentioned, as I said, uh, you have a lot of potential. Microservices, you can, thanks to Kubernetes, you can work that in a multi-cloud environment, every environments. You can even have that on premise, right? And all that is achieved with containers and this model of infrastructure as code, right? But as I said, all this actually generates lots of complexity. Unless you know how to handle this complexity, you will be in trouble if you get into these containers and Kubernetes. And in order to handle complexity, you have to have very clear you have to understand, and the whole organization actually has to understand the agile and DevOps principles. That's essential. I'm not going to extend much on these two topics because this would be really another session. But note that when you get into Kubernetes, cloud native, and all these kind of things, right, you will find out lots of terms that are related to these agile and DevOps principles. You will see a lot, you will hear a lot about continuous integrations, continuous delivery pipelines with integration, delivery, and deployment of your application. You will hear about GitOps, ML ops or machine learning ops, DevSecOps, security operations, right? So all these are related to these two principles, Agile and DevOps principles. So keep in mind that you have to understand really how to manage the complexity that these new modern applications are bringing. And now, just to finish, part of this complexity, right? The way to handle that is automation. You need to establish, when you go seriously with containers and Kubernetes, you must establish a proper automatized continuous integration, continuous delivery, and continuous deployment pipeline. If you don't do that, you will have difficulties to have frequent high impact changes into your application, which is one of the main goals that that the cloud native approach is trying to push for. The same with the day two operations. You will need to automatize once you deploy the applications, how to handle that. Things like backups, security checks, all these kind of things. If you don't do that, due to the complexity of these applications, you will end up doing a lot of manual work and you will have a very low productivity. If you want to know how good you are in applying the Agile and DevOps principles, well, just check how often you deploy your applications into production. If you are doing that every 3-6 months, that means that you are still in the waterfall area. So you have a lot of things to do there to improve. If you are doing that weekly or bi-weekly, well, you are very close. You are doing pretty well. But if you, in order to get really excellence in the way to have these frequent high impact changes, you should be thinking of having the deployments done every day, several times a day. Okay, until you don't achieve that, you haven't reached that excellence level. So automation, automation, and more automation, and always include security, of course, in this automation, right, is the key to be successful with Kubernetes and containers. And if you do that, actually, I can guarantee you that the developers and ops will be happier. Developers and ops want to build new things. They want to make a change, right? Make an impact in the business. If they spend their time just I don't know, fixing things, actually, they won't be very happy. And these days, that it seems like the retaining people is so difficult. Well, unless you provide something like this, you will have many chances of people leaving the company to find something better. Okay, so I will finish now, definitely, just talking about the tooling that you will find here. There is a lot, so I'm not pretending here to say what tools you have to use. It's just to give you an example. What I did is actually divided into several areas. So I'll start with the containerization. Tools to create images, Docker and Podman. There are many more. Image registry, you have the Docker Hub, and you can, which is public, yeah, and you can use that, or you can build your own registry. You have hardware there, which is a very useful tool. To check the security of your containers, then you have Docker, you have Trivi, Anchor, Claire, plenty of tools that allow you to check the vulnerabilities of your images, right? Container images. If you want to create a cluster, what I said before, installers like QADM or distributions like Rancher can help you out to do it by yourself. But if you don't want to do that and you have the money to do so, you can actually get the services of a cloud provider that provides a Kubernetes as a service. Okay, so for development, use this Minikube kind or K3D tools that I mentioned before. As you saw, it's very easy to set up a Kubernetes in your machine, so you can use these tools for your development process. Now, automation. For provisioning the infrastructure for your own Kubernetes, you have good tools like Terraform or Pulumi that allow you to do that in a infrastructure as code way. Okay. Regarding the continuous integration, continuous delivery pipeline, many tools that are available, a lot, right? But you will be probably using Git or something similar. You have GitHub Actions, Jenkins, that is, it has been with us, I think, for forever, like 20 years. And then tools like Argo CD that help you implement GitOps strategies. Even for development, when you are doing your own code, you have two tools there that are very useful, Scaffold and Octet. Regarding orchestration, the one I mentioned before, kubectl, when you start building containers, or when you start deploying microservices, you will notice that you will have lots of YAMLs. So there are tools like Customize or Helm that allow you, that help you out to manage the big volume of YAMLs that you will end up, using templates and similars. And then finally, a bunch of different projects that are available for you and that you can use for monitoring, for creating a serverless environment, for managing storage, for security, for service mesh environments, for backups. So there are plenty available out there. I just mentioned a few here, but believe me, the number of projects that are out there is just amazing. Again, you can go to the data on Kubernetes channel, and then every day probably you will see a new project being presented that is more than likely open source. Okay, now this amount of tools could be overwhelming, so if you are just starting, my advice actually would be to go with something smaller, right? My working with Linux is always a good thing because many of these tools are very much Linux based. If you want to learn about Kubernetes, about containers, sorry, you will use Docker. I think it's a great tool that you can still use and learn all the details of how to manage containers. And if you want to start playing with Kubernetes, build the cluster in your own machine, right? You have Minikube, K3D, also the kind tool that I mentioned before. Just do it yourself, install also kubectl, and then you can start taking different projects and installing them in your own machine and trying to and learn how to use them. Okay. Woo, I think I took maybe longer than expected, but Bart, I promise I'll finish now, right? So
You're
some
doing fine. You're
takeaways
doing
here.
fine.
Sorry?
You're good. You're good. Don't worry.
Okay, great. Thank you, Bart. So some takeaways. Kubernetes and containers are part of a paradigm shift. Yeah, the one I told you. It's a change in the way we build applications. So the Kubernetes is also a cloud native project, okay? The cloud native approach promotes a cultural change to build and manage modern applications. And this cultural change is something difficult to achieve because we are already used to do applications in one particular way. Moving into this other way of managing this is going to be hard for many, okay? And then maybe the last takeaway, all big software cloud infrastructure companies and a great community are backing Kubernetes and containers. So now is the time to start with this. And my advice will be to go cloud native with Kubernetes and containers. Okay, I'll finish with that. Thank you for your time. I hope that I didn't extend too much, right? And probably this was something longer than a brief introduction of Kubernetes, right? Here you have my details, right? If you want to contact me, well, you can check our LinkedIn channel in Lainotik. And I am also within the Data on Kubernetes Slack channel, so I will be there. So hope you enjoyed the presentation, and I leave the rest for you, Bart.
I think we can all agree that the presentation was very, very good. We had
Okay,
lots of
thank you.
comments, lots of feedback in YouTube. We can just ask really quickly.
So I think I went that fast that I'm not sure what I said in all this hour.
No. Like I said, people were following along quite well. So I'm just polling the audience right now to see what everybody has to say about it, just to get some final feedback. But obviously there was a lot of stuff covered. But once again, for everyone that's out there, the recording's going to be going up. If you want to watch that again, if you arrived late, it's not a problem. Also remember, please, as Aitor mentioned, get in our Slack. You can contact him directly. He's happy to answer questions. He'll answer them patiently and very methodically. Maybe he won't be able to answer them just right now, but he's going to get to them, all right? So, anyway, I thought we're getting tons and tons of great feedback. Yeah, you wonderful audience that we have here.
I hope it is a good feedback.
No. Great energy, great energy. Anyway, awesome sessions, and the slides were too good. Amazing. Love the session. We got some really, really positive folks.
Okay. I'm happy to hear that. Very happy.
Great feedback. Now, this is where I want to get to. All of you have been paying attention to Aitor's session. How many of you did, I don't know if anyone was in the last session that we did about Docker, but the challenge that we did there, all right, because some folks were asking earlier as well too about swag. You can win swag. We want to give you swag. We want to give you DOK t-shirts. We want to give you DOK hoodies. We want to give you stickers from Civo. We want to give you all these different things, okay? So what I want to say here is this, all right? Some of you, I'm going to link this right here, a YouTube link to a video that was produced by someone who was watching the session, all right? A young man who was watching the session with us. And hold on, let me see. Let me make sure I get the right link because we've been having some issues with links earlier. So this was a sort of summary that was created of the last, like I said, the last session that we did. And what we want to do this time is to put out a similar challenge. All right. So all you have to do is we'll give you a deadline between today and tomorrow to write a summary of what you learned today on LinkedIn or Twitter. You can do one or the other. All you need to do is write a summary. I would prefer LinkedIn, all right, just because it's kind of easier to follow. All right. Yeah. So if you saw that video, that was really, really good, right? So what he did is that he wrote a summary of the things that he learned about Docker. What we would like you to do is the same thing, just applying that to what we did today with Aitor session, okay? So whoever creates the best summary, writing a summary of the things that you learned, your learnings, on, like I said, LinkedIn's probably preferable to Twitter, just because with Twitter, with writing in comments one after the other, doing a thread, it's okay, but it's not really ideal for us. If you put it on LinkedIn and you tag me and you tag Aitor and you also tag Data on Kubernetes, the community, then we will be looking at those things over the weekend. And next week, by Tuesday, we will decide winners. All right, and those winners will be announced in our Slack. Okay, so if you're in our Slack, we'll notify the winners there. And the best winner will have a video made out of their description. Remember, your description, your summary can be 250 words maximum. All right, if it goes over 250 words, you can't consider it as a winner. Right, it needs to be to the point. All right, it needs to be to the point, so we can see exactly what you learned. What were the key things that you learned? Say it in your own words. It's also really important. In the last time we saw some folks that were very ambitious, but we could tell that some of the information they were copying from other places. We want to hear from you. It doesn't have to be perfect Shakespearean English, but we want to see a nice, clean summary of the things that I was talking about. So like I said, that's what we're looking for here, all right? So that's one of the things about winning swag. Then the other thing for the folks that arrived late, and the DOK, the Data on Kubernetes community, we're very happy to announce that Kunal is now going to be our student program manager. And that means that Kunal will be coordinating interns with us. So like I said, we're very, very excited to announce that. Kunal has been collaborating with us for a while. But like I said, that's another piece of news. If you want to find out about that, get in our Slack. I've pinned the information to apply to be an intern in there. So if you're interested in doing that, you have all the information that you need to do that. But we do have kind of a tight deadline on that. You'll see it's in the documentation there. We want to get that going. We want to get our new interns onboarded next week so you can immediately join our team and start working with us. So like I said, we've got those two different opportunities. One is to write a summary on LinkedIn of the things that you learned today in the session. You can link the video as well too. As soon as we finish the session today, the video will be available on YouTube, so you can link that in your summary on LinkedIn. Like I said, 250 words maximum. Tag me, tag Aitor, tag the Data on Kubernetes community, and we'll be happy to take a look at those in the next few days. And like I said, the winner, the number one winner, will have a video made for them in the same way that we did for the previous winner, right? For the session about Docker, the one that I linked here in the YouTube comments. And then the other opportunity that you have is to be able to, as I said, to apply to be an intern with us in the Data on Kubernetes community. Just seeing a question here regarding the slides. The slides are not going to be available, all right, because they have to be used for something else. So the slides, you'll be able to see them just in the video. All the information will be there. You can just go piece by piece fast forwarding. You can get slides that way if you want to take screenshots or things like that. But the actual slides themselves do belong to Lainotik, and they have to be used for other things. So for reasons of privacy and originality, they kind of want to hang on to those for right now. So for the time being, just for this particular challenge, just use the YouTube video. You'll be able to see everything there. If you have any specific questions as well, you can ask Aitor in our Slack. So that will, like I said, that will be available to you. That being said, Aitor, can you stop sharing your screen so I can share mine?
Yeah, of course. Yeah, sorry about that.
No, it's all good.
I was just surprised to see how many homeworks that you are giving to people.
So. Oh, no. But we have a really enthusiastic audience that's pretty awesome. So I'm very confident that they're
okay, great.
Now, let's take a look. So now I got to get somewhere else because I think for those of you who have attended our sessions before, you know that we like to do things differently. And one of the things that we do differently in our community is, as you saw previously, we always have a little bit of music, all right, a little bit of rap every time we can get a chance. But we also really like to incorporate art, all right? So some of you may have seen in other sessions that we've done that while this is going on, we have our artist, Angel, who goes by Ardiluthu, who you can find in Twitter. And while we're doing these sessions, he's in the background creating a visual representation of the stuff that we're talking about. Aitor, can you see my screen now?
Yeah.
Good. So you can see all the different things that building on what was talked about in Docker, but then now taking this into the Kubernetes world. Obviously, there are a lot of things that, to get everything that I talked about, it would probably take about 5 to 10 different drawings. But I think that Angel still, as always, did a very good job of creating this visual summary. So once again, as usual, well done, Angel. We'll be sharing that in Twitter very soon. Like I said, if you've got questions for Aitor, you can definitely very easily reach out in our Slack. I believe Kunal has now rejoined us. So we're going to get to his part of the session now. Thank you very much, Aitor. Kunal, it's all yours. We don't have a ton of time, so we're going to have to run a little bit, hurry a little bit here. Yeah. But if you want to share your screen, Kunal, I think you might be muted. No, you're not?
Oh, no, I'm not.
All right, tell you, man.
Cool. All right, welcome everyone. This particular session is more about let me just share my screen real quick. Cool. So this session is about college to cloud native, and we're going to be talking about how you can get involved because even though you can contribute to open source, irrespective of whether you get selected for a program or not, which is great. But there are a few mentorship programs and a lot of mentorship opportunities, a lot of groups you can be a part of, resources, for example, for you to get started. So before we get into it, I just want to share that open source is for everyone and every contribution counts. Even though the CNCF has one of the largest, so many projects. So if you see CNCF projects, right? So these projects are really big. It's they are being used by people around the world. You can also check out the entire CNCF landscape if you want. There was a really big yeah, this is the one I'm talking about. So you can see so many particular projects that are available over here. My page isn't even loading. That's how many projects are here. So the thing I would like to share is there are two approaches, right, to choosing a particular project. So one is the top-down approach and another one is the bottom-up approach. So first you for example, a particular tech stack and then you choose a project that uses that tech stack. Another reason can be you know a particular project you want to contribute to, and then you learn the tech stack that is used in that project. So in any way, these things go hand in hand. So if you're a student, you might find yourself in a place where you're contributing to say Kubernetes or something. You might find yourself in a place where there are many technologies or many terms that are being used that you don't know much about. So just a bit about this. Don't be overwhelmed. It's a great learning opportunity for you, and we'll talk more about how you can get started with the actual contribution part. But that is what I would recommend, that have an open mind to learn and explore. And yeah, cool. So these are the CNCF projects. You can see the graduated, incubating, and you can see about these. So let's pick up any one project. Let's say Kubernetes itself. So if you just go to the GitHub repository, Kubernetes. Okay, so basically you can see there are 1.8 thousand issues. The thing I want you to do is click on this particular link which says good first issues. Now, before actually diving deep into this, it's good to know, what Kubernetes is, and not just for Kubernetes, but in any project. It's good to have a basic idea, what the project does before you want to get started with it as a contributor. So some resources I can share with you is, first of all, the Kubernetes website. This is the best, one of the best resources. So it has like, tutorials, and the documentation is amazing. A session like this, the series that we're doing on Kubernetes, that is going to help you get, up and running. If you have any doubts, join the DOK Slack channel and ask your, can feel free to ask your questions over there. One thing I would also recommend is ask your questions in public. And yeah, second thing I would, just one second. The second thing I would like to share is, whichever project you are trying to be a part of, join the mailing list or like the group chat for that particular project. For example, Kubernetes has a Slack channel. So join that Slack channel, and especially for students, if I'm sharing resources, then there's a students channel in this Kubernetes group. Now notice something, Kubernetes itself is a really big project, and there's like a lot of modules and SIGs over here that we cannot obviously go in this particular session. But one thing I would like to share with you is, watch this playlist. So this is the Kubernetes Contributor Summit playlist from San Diego 2019. It explains you everything related to how the repository structure, how to start contributing, and what are the various SIGs you can be a part of, and all these other things. Yeah. So I'll just share it in the chat, and maybe Bart can put it in the channel or the YouTube. Yeah. So you can see. Yep. So do watch these particular sessions. It's like very good in terms of understanding the ecosystem, and how do we actually get started with the contributing. So you can see getting up and running and setting up the project and everything. The thing I like about this is they even showed us, people, when I was there in San Diego, there were 2 tracks. One was the very, very beginner track. So they were literally starting from the, basics of Git and GitHub. And one was the intermediate track for people who know about coding, and they can also start contributing. Cool. One more thing that I want to share with you, because we are like a bit about a little lack of time, but non-code contributions are also very valuable. So this is the second link that I would like to share. Bart, maybe you can share this. So this is the panel from KubeCon, the recent KubeCon EU, which is your path to non-code contributions in the Kubernetes community. So it was a really great talk, and basically, the panelists have shared how you can get started with contributing to Kubernetes as a non-code contributor. Non-code contributions are very important. It's like it's not that the community is only being run with coding contributions. If there's no documentation, then that's a really big bummer. Documentation is crucial. Contributor experience, surveys, and all these other things, communications, for example. So these are like major roles in such big projects. So most definitely check this out. This is not just like Kubernetes specific. The tips that they have shared in this also hold true for many other big projects. Cool. So this is something that I'll also share. So go to this link and check out the projects and get started. The important thing is just getting started. Another thing I would like to share is DIMS has a really nice resource for Kubernetes. Maybe he has pinned it somewhere. Okay, he hasn't pinned it, so we'd have to find it. But DIMS had a really nice list for Kubernetes. I'll share that in a while in the channel. Maybe I have it somewhere. Let's see. So yeah, basically getting started, like Dim's also mentioned, like getting started is the most important part. So coding Kubernetes, there's so many folders, it's like crazy. Where is Kubernetes? Contributing.
I can get it. Don't worry.
Got it.
I
have these. Yeah, I have these for a reason. This is, you can see, such a great list of resources. So it has like beginner resources, developer resources, and all these other things. Everything is mentioned in one place. Even like some tutorials, and Katacoda.com has some courses for hands-on experience. Cheat sheet. This is like a really golden list, So I shared this in the chat as well. So make sure you check that out. Cool. All right, so now you have found a project, you know how to get started, you have interacted, and if you want to learn more about like how do you step into an open source community, check out the meetup number 1 of DOK and Civo that we did last month, where I talked about basically how to get started with open source and stuff. And make sure you hit the subscribe button for DOK because a lot of nice streams are coming your way. That rhymed. Bart, you're not the only one who can rhyme.
Oh,
Okay. Cool. Second thing, let's talk a bit more about mentorship programs. CNCF/mentoring is a repository. So mentorship programs, let's talk a bit more about that. So even though you can contribute to open source in your own time, anyone can get started. And there are particularly a few programs that help you, get started basically. So these are like for beginners. If anyone is a beginner who wants to get started with contributing to CNCF, so many projects take part, and many mentorship programs are available. So you can see for research, there's the LFX mentorship program, Outreachy, which promotes diversity in open source, Season of Docs for people who really want to contribute to the documentation part of the project, and Google Summer of Code, which is something that many people are already aware of. So as you can see, if you look into the LFX mentorship program, you can see 2021 program over here, and you can see summer. So you can look more about the timeline. So you can see spring term is going on from the summer term going on from June 1st, August 31st, and all these other things are mentioned, like the duration, and there's the list of project ideas are mentioned over here as well. So you can see build packs, core DNS, Cortex, and Kubernetes, KubeEdge, and so many projects will be let's say participating. So you can see a recommend skill set, the mentors, issue link, description of the project, what the idea is, for example. So this is what I would recommend you to go through. Obviously this is going to take some time, and that is okay. Give it time, go through the previous trends as well of the projects, what type of projects are being selected. So you can see for the very first part, there were only 2 to 3 mentees or 4 mentees. So relatively new program, but it's now growing very much. As you can see in 21, there were some 70 plus, I believe, students a part of all the programs combined. Outreachy again, it's a great program. I'm not sure if it's if they're taking part right now, but do keep an eye out on this particular doc. This particular one. Where is it? This particular one. Cool. So Kubernetes and taking part. So you can list the SIGs and everything. In case you're wondering what are these SIGs, then I have already shared the resource for that, which is the Kubernetes Contributor Summit videos. They have explained it brilliantly. Also, all of these individual SIGs SIG is basically a special interest group. So like groups in the Kubernetes community, and they have their own regular meetups and stuff as well. Another thing I would like to share is there's one more thing. You can see so many opportunities are there. It's hard not to feel overwhelmed, but that's fine. Just keep applying and give your best. Contribute, with the motivation of learning and being a part of the community, and not with the motivation of just getting selected in these programs. Because if you're doing good work, your application will already obviously get strengthened. For example, Season of Docs and Google Summer of Code. So CNCF takes part in Google Summer of Code. Google Summer of Code, for those of you who are not aware, it's a remote educational track, and basically many organizations take part. CNCF is one of them. So Summer of Code with google.com. If you click on the organizations tab, so you can see this, so many organizations take part. If I just write CNCF, you can see CNCF is taking part this year as well. This is the link you need to create, which is view idea list. And these are all the ideas that are taking part in Google Summer of Code this year. Cool. So you can see all the links are mentioned, mentors are mentioned, tech stack has been mentioned. Another thing that you can do is open source is for everyone. So if you want to contribute to some other organization that is also doing good work, that's fine. So let's say you want to contribute to some organization that is using Node.js. Just write Node.js over here. You'll find Node.js organizations. If you're using Java, so write Java over here. Now you'll find organizations using Java. Cool. So how easy was it to now find organizations related to your tech stack? If you don't want to do Google Summer of Code, that's fine. This website is very good in terms of finding organizations as well. You can also go to GitHub Explore tab, explore repositories, and you can search on the basis of topics. So like React or JavaScript, Python, whatever. So it's going to then list all the particular projects that are using React. Pretty cool. All right. Some best practices I've already shared in like the session number 1. So make sure you check that out. And last, but like there's one more called Season of Docs. So Season of Docs is also a Google open source program, which is basically for technical writers. One thing I would like to mention is this is for students. Season of Docs, so Summer of Code is for students. Outreach is for everyone. LFX mentorship is for everyone as well. So even people who are working professionals, they can also apply. And everything is mentioned over here. So you can see the program statistics. Recently, they were like in year 2020. So you can see in 2017, they were like just 8. 2018, only 8 mentees. 2019, when first community breach came, there were only 4 mentees. And now they have like 50 mentees, in total 71. So you can see the exponential graph, So it's good. And we'll try to share more about it so that more and more people can apply. Most definitely, this is going to be one of the more really popular programs because it's doing great work. You get a stipend, you get the mentorship, you get to work on real world projects. And I have seen many people who have become maintainers as well after contributing to such projects. All right. One more thing I want to share is CNCF student community group. If you haven't joined already, please do so and check out us on Twitter as well. So Twitter is basically CNCF students. Keeping it simple. I'm so lucky this was not taken. So this is nice. CNCF students. So do follow and share about it with your friends. We do some amazing sessions. You can see, where is it? This one. You can see so many past events. Just list keeps going on and on. We have some nice sponsors here with Civo. Oh, by the way, Bart, have you shared about the winners and stuff, how they can participate?
Absolutely.
Yeah, so we'll be giving out obviously the DOK video feature and hoodies and stuff, and also 10 people will be getting CO swag. So all you need to do is send in your summary, and we'll reach out to
make it easier just to post it directly to LinkedIn, and then we can take it from there.
I guess we can share it on LinkedIn, and you can tag CNCF group, tag Civo, and tag DOK. Cool. So either LinkedIn or Twitter, that works. Alrighty. Cool. It's important to share your learnings. So we're not just saying, just share about this session or whatever. No, share about what you learned. Share about the good work you do in the community, not just for this community group, but in general, if you're doing any other good work, if you're doing some nice open source projects, or if you're helping someone, and do share about it in public, because Kelsey Hightower said this, only thing better than helping people is helping people who help people. So if you share good work you do, and you will get other people will see, they will also get motivated, and they will try to help you as well. Last thing I want to share is Kubernetes Shadows program. So basically, Shadows program is you can, oops, not this one. Yeah, so you can join the Kubernetes release team as a shadow. So you'll be like mentored, and you'll be working with the release team for the Kubernetes cycle. And it's basically training future release team leaders. So if you want to learn about how this process goes, like what you learn and how do you apply it, this is the link for that. So I'm a part of release team 1.22, learning quite a lot, and I'm part of the comms team. So we work with like the docs, docsig, and the enhancement. So it's going pretty good, learning a lot, and it goes on like I believe quarterly. So you can apply, for the next release cycle. Forms will open, and whenever the forms are open, I'll share in the Twitter handle of CNCF students group. So make sure I don't know if on Twitter it shows some notification or something. So yeah, do that. That was pretty much about it. Shared a lot of resources and a lot of links. Hopefully that would help you get started with with being a contributor. Again, if you have any questions, I would highly recommend keeping all the questions public, asking relevant questions. Most of the things are already available online. So before asking some technical questions, for example, or some resources, try to Google a little bit and then ask even more specific questions, because that will be a very good impression on your part, because okay, this person is asking good questions, they're actually putting in efforts, and if you ask good questions and provide enough context, you will get a reply much faster. So if you're just going to say, if you're just going to put a message like, hey, I am facing issues in Kubernetes, I mean, what issues?
Show that you've done the homework, show that you've read some documentation, make some kind of an effort, make it clear, but I completely agree. Kunal, that being said, we got to run because we literally have meetup number 61. If you're interested in machine learning, next meetup that's going to happen in 2 minutes will be about that. We got tons of links into the YouTube chat. Amazing session. Welcome, Kunal, as our student program manager. This is going to rock. You've got all the other info about internships, all that kind of stuff in our Slack. You've got all the info as well, too, about how to get some swag from Civo, from the DOK, CNCF, etc. Big shout out to Aitor. Amazing session about intro to Kubernetes. I got to go because we got the next meetup. Take care, everyone. We'll see you soon. Lars. Hello, Lars.
To watch for sure.
Good. I'm glad you liked it. Let's see.
Let me see if I can. All right.
1 second. Okay, cool. All right, cool. We're going to go live right now.
All right, let's do it.
All right, let's do it. Good. All right, and we are live for the second time in one day. I was just talking to Lars about how just going from one to the other is a little bit chaotic. We just literally went from meetup number 60 to meetup number 61. And here we are, joined by Lars. Good afternoon. I believe we are at the same time. How are you doing, Lars?
Yeah, great. Thanks for having me. It's yeah, really interesting to see the other talk as well. And yeah, glad to be here.
Good. So obviously we're changing gears a little bit. We just came out of an intro to Kubernetes session. If this is your first time, welcome to the Data on Kubernetes community. You've got all of our links in the YouTube description if you want to check us out on Slack, on Twitter, on LinkedIn. As you can tell, we're doing lots and lots of meetups about lots of different things. I have to say that machine learning is a hot topic. Lars, why is that? Why is it so cool?
Why is that? Good question. Maybe I feel like it has something magical about it, right? Like the first time you see like AI do something that you thought computers could never do, like I think that does something. So I think that's the main reason.
Okay. So if, in your experience, what was the first time that you really encountered AI?
Oh, good question. That must have been like in university. So I actually had so my background is in computer science, and I remember having a course about AI, and yeah, I mean that starts off with like like Deep Blue. I don't know if you're familiar.
Oh
with Deep Blue.
yeah, Gary Kasparov. Yeah,
Gary
chess.
Kasparov. Exactly,
Man,
right.
Man, that's super cool. That's cool.
Yeah. That's really cool. So that's actually what the course started with. And once you start digging into it and start finding out how these things actually work, yeah, that there's just something about that, and the end result of building a model or an algorithm and just seeing it live a life of its own and do its own thing. I think that's pretty cool.
It is pretty cool. So the thing is, Deep Blue, that was in the 90s. I mean, I'm old enough. I'm pretty sure I'm older than you, but I think that was in the 90s, right?
Yeah, I think so. And I wasn't even alive back then, but like just watching that mesh unfold, it's just really, really interesting. Yeah.
Cool. Talk about other things that you like, because we saw this in the description. You're also into Chinese culture and meditation. Tell us a little bit about that.
Oof. Okay. Yeah. So maybe meditation. So yeah, I got in contact with meditation in general. I think about 2 to 3 years ago. I didn't think much of it at the time when I encountered it, but later on, I think it was a couple of months, maybe a year after, I first talked to people that knew about this. I felt like I could really make use of some of the practices in there. And for the past 2 years, I have been making use of that. So I'm meditating daily and trying to apply meditation practice in my daily life. And I can always say it has really, been very beneficial so far. And I'm really enjoying doing this and getting the benefits from it. So
that's good. I mean, I think you picked an interesting time to start doing it, because with everything that we've been going through as a planet, I think it's probably a good time to get some balance in that. We can maybe take a look at that a little bit later. But that being said, if you want to go ahead and jump right into your presentation, as usual for folks that are in the audience, if you've got questions, put them in the chat. We'll get to them accordingly. But without further ado, Lars, if you want to go right ahead, I just have to ask, do you know Tim Vandekeer? Because he's asking already about your plants.
Already. Oh, that's quite quick. I don't happen to know him. I have seen him around.
You will very soon. He's an amazing community member of the DOK. So anyway, no, but he was very complimentary of your plants, and I do like your plants. Plants give oxygen, so that's good.
Thanks. Yeah, it's really nice. It's very nice to have these around me, and they bring some life to the environment.
Absolutely. Good. So
let's see.
If you want to share your screen, jump right in.
Yeah, let's see here. See if I can share it. I'm not using Zoom a lot. Can I share like an individuals tab here?
Don't worry. Yeah, we're all getting used to different tools.
Yeah, definitely. I think I'll use my entire screen here.
Okay. Yeah.
All right.
Like I said, I'll be monitoring the YouTube chat for questions. So if anything,
sure.
I'll just chime in.
All right. It looks like I'm gonna need to have to give Zoom some permissions to actually record my screen. So I'll be right back.
That's okay. No worries. In the meantime, we can think about different meditation strategies. Seriously. And the thing, because I'm a really impatient person. So like the idea of like, oh, I'm going to sit still for, 2 hours at a time and be quiet is something that in my mind is just like inconceivable,
Right.
But the good thing about meditation is that it doesn't have to be a religious thing. And there are lots of different kinds of meditation, I think, as well. Is that for people, like I like running. And I think in some ways running can put you in a meditative state because you're concentrated, you're focused. But just getting, 5 minutes to sit quietly. And also for people that aren't that into it, if you just go to YouTube and look for mindfulness meditations, there are tons. You can get 1 minute, 1 to 2 minutes, 5 minutes, however the amount of time that you want to dedicate. But yeah. Oh, good. We're already getting some lively stuff in the chat. This is good. This is the power of improvisation. Because you just never know what's going to happen. But looking at these different things and thinking about, the future of what can machine learning bring to meditation and what can meditation bring to machine learning? I think that's a question that we'll probably have to tease out a little bit more once we get Lars back with us. Oh, there you are. You're back. Good.
Here we go. Yeah, it took some time, but we're back.
Well, good. Right, that's part of the magic. This is part of the fun.
It is. So let's get the show on the road, shall we?
Let's do it.
All right. Let's do it. So, yeah, so I was watching the previous talk just now, found it very interesting. And I think, like having the intro into Kubernetes is a very, nice intro into what we're going to actually do now. Perfecting machine learning workloads on Kubernetes. I think it's good to start off by highlighting the need for this talk. And I think this tweet that I found describes it really well. It's by Gina. Gina is not relevant to the story, but she's actually quoting someone here. So I'm going to read it out. The story of enterprise machine learning. It took me 3 weeks to develop the model. It's been over 11 months and it's still not deployed. And this was actually a quote by a guy called Dinesh, who is an automation engineer at IBM. And if this is true, something's actually going wrong here. And I think there's a lot to that we can win here. So this was in the start of 2018. As you can see, the tweet was in 2018, but it's not much different, today. And we can back that up with some statistics. Which is that actually 87% of data science projects don't reach production. This was the result of a report that was done by Gartner, who's a big IT consultancy firm. And there's multiple other studies that actually come to the same conclusion. And what the Gartner study actually shows is that there's two main causes for the fact that they don't get into production. The first one is the data quality and data availability. So for most companies, either they don't collect enough data to do machine learning, or they do, but the data is very scattered inside the company, and therefore it's just not possible to build a machine learning use case. The second main cause, and that's the one I want to talk to you about today, is the lack of collaboration between data scientists, IT, and engineering. And I think this is one of the main problems, basically because all these people that we see here, data scientists, IT, engineering, they all speak different languages, and they all have to, all these stakeholders in these machine learning projects need to come together and understand ML, machine learning, understand the tools, understand the problems that they're trying to solve, and that's pretty tough. I think that's what makes machine learning a very tough problem. And
that is a great. I think you said the stakeholder. Oh yeah, you can handle the algorithms. But this is such a common theme, and I think it's also great to start out with like these human sort of elements, whether it's interest in culture, meditation, things like that. Is because as much as we talk about technological problems, we're always talking about people problems. Like you said, people that don't speak the same language, or that there's tension or friction or silos or all these kind of things. I think the kind of question is, how can we all get more empathy into our organizations? Anyway, I'll let you handle that.
I really like that comment, Bart. I think that's really the case. And yeah, I think that's, if you can tackle that problem, the tech will follow. Even though we need skilled tech people, I think that definitely comes next. Yeah. So to conclude this slide, basically, as we can see, engineers are also part of the problem, right? And seeing as I have a background in computer science and I do some engineering, I feel it's also my responsibility to help solve that problem. Yeah, let's do that today. So I want to take you through 3 different sections of this presentation. And the overall goal of today will be to help you deploy machine learning workloads on Kubernetes. So I will start out by giving a brief introduction of what machine learning actually is, and I will gear it towards the engineering mind, if you will. Because we don't need to get into all the data science nitty-gritty to be able to deploy models. In the second section, we'll see how we can deploy some machine learning use cases and specifications that we get to actual Kubernetes deployments and some of the tools that we can use for that. And in the final section, we'll have a quick demo and show you how we can actually do that and implement a use case. So before we start, who is this guy and why should he be the one to tell you or to inform you on how to do this? So again, my name is Lars. I have a background in computer science. I hold a bachelor's from Leiden University here in the Netherlands. After my bachelor's, I started off as a machine learning engineer at a consultancy where I had the chance to help many different companies actually implement their machine learning use cases. After that, basically a spin-off of that consultancy, I started working as a software engineer at Deploy, where we tried to take all the learnings from the machine learning implementations that we had, at those companies and merge them into a product that could help solve some of these problems. So that's what I still do today. Next to that, my main interests, professionally are AI, machine learning, and also distributed systems. So, that's where the Kubernetes part comes in, but also, distributed ledger technology. And yeah, Bart already briefly mentioned it, but yeah, I'm really in love with both meditation and plants, which is not relevant for this talk, but just there's some nice back.
It is relevant for this talk. It is relevant for this talk. And Tim actually even asked, what kind of meditation do you do? If you want to share that.
What kind of, so I mainly practice two kinds of meditation, mindfulness meditation and open heart meditation, of which most of my time is spent on mindfulness meditation.
Can we get like a 20-second definition or like the difference between the two?
Yeah, sure. So mindfulness meditation really tries to help you focus on the present, being mindful of the present. So, one of the techniques that you often hear is focusing on your breath. And with open heart meditation, what you really do is you try to focus on emotions, how that makes you feel. You can meditate on certain connections that you have with other people, and what you feel in them. And I know it sounds all a bit fuzzy, but once you start digging into it, there's some hard science there. So
Anything we talk about in the Data on Kubernetes community sounds plenty fuzzy. What you just described sounds amazing and very practical. Anyway, continue.
Nice. I like hearing that. All right. So let's get into the first part of this presentation, which will be the machine learning for engineers. And let's start with a machine learning 101. So basically, we have to start at like a problem, right? Because machine learning solves a problem. And that's some problems that are very hard to solve with regular software. And that's basically because some problems just have such a high number of parameters that are involved in those problems that it's near to impossible, if not impossible, to solve it with regular software. So an example would be, and this is a very common example in the machine learning space, is the handwritten digits classification, or MNIST. And the goal of this classification is to take a handwritten digit, like one that you see in the corner, and classify it as being a digit. So let's say we take like one of the top images, we want to classify that as being a 0. Now, if you start looking at, how can I solve this with traditional software, or I wouldn't say traditional, but regular software? This is pretty hard. So I think the image here is about 16 pixels by 16 pixels wide. 16 times 16, help me out here, is that 256? I don't know. It's like 2 to the 56, 2 to the power of 56 amount of possible states that this image can have. And if you have to program that with like if